Alright, this is a quadratic question. So we have a quadratic function. Find the equation of axis of symmetry, which is the vertex. So first of all, we have A, and then the axis of symmetry, it's negative B over 2A, as we always do. So negative B over 2A, so that will become 4 over 1, that will equals to 4. Remember, x equals to 4, that will be our answer. And then we have to write it become this one, and then we have to write that. So this definitely is the x. So we for B1, remember the equation, all right? So for h will be equals to 4 because it's the axis, and we can just expand this one. So for the k, we will have fx equals to x squared minus 4x plus 5. This is the original question, and then x squared minus 2ab, which is 2 times 2 times x equals to 4x plus 4. And then because this is a 5 here, I have to make it become 1. So therefore we have x minus 4 all squared plus 1. And this is k should be equals to 1. 4 marks. Here we go, we have a trick question. We have an identity, we have a ratio here, and this is acute, which means that everything is, so this is everything should be positive. Then, no matter what, I'll draw a right angle triangle here. So that is the angle and sine. So OH. So we have this angle will be 9 minus 5. So we have 4. So that should be 2. Now we have cos theta will be equals to 2 over 3 because like AH. Then for B, we got cosine 2 theta. Using our identities in the data booklet, you will have cos 2 square minus sine 2 square. Make sure you write that to acknowledge you know the double angle formula, and then we just use our information here. And then we have negative 1 over 9 as the angle. Nice. Coming up, we have a binomial expression here. So we have the angle here, 1, 4, 6, 4, 1 for the 4th row. So the 5th row will be just adding up. So we have 1, 1 on each side, and then we just add them up. So we have 5, 10, 10, and 5 here. So make sure you write the answer at the area we have. So we have 1, 5, 10, 10, 5, 1. That should get you enough mark. Make sure you give the comma, otherwise it doesn't work. So for B, we want the third term of this bit. So we have the third term. So 5C3, we got 2x equals to 3, and the 3 equals to the power 2. So we have 5 terms, so 0, 1, 2, 3. So it's 10 times 8x cubed times 9. So we have 720 to the power times x to the power 3. And that gives you nicely 5 points. Here we go, we have a factor equation here, factor question here. So first of all, we're asking for a factor equation from 2 points. So first of all, going through PQ, we need to find PQ, the one behind minus the one before. So we have 7, 3, negative 4, minus 1, minus 2, and minus negative 1. So then ends up, we will have 6, 1, and negative 3 for the factor. So, and then we write our factor equation. So we have x, y, z would be equals to position vector either of the point. So I'm using 1 to negative 1 plus t, the direction vector. And B, find a line going through PQ is perpendicular to this. So find the value of n. So which means that perpendicular means that the dot product equals to 0. So we dot them. So we have 6, 1, negative 3 dot 2, 0n should be equal to 0, which is not hard. So all you need to do is 6 times 2 plus minus 3n equals to 0. So throw this to the other side. We have 12 equals to 3n. And therefore, n should be equals to 4. And there we go, another 7 point. Coming up, we have a probability question. They told me it's an independent event and the intersect is 0.2 and the A not B and not AB is 6. So I'll draw a diagram for myself. So A and B. This is 0.2 in the middle and not A plus B is 0.6. So that will get us 0.8. So for A, this is the step. Make sure you draw that too. So A, probability of B will be equal to 0.2 plus 0.6, which is 0.8. Nice and easy from there. And then B, we got the union here. Remember our formula. Probability of A union B will be equals to probability of A plus B minus probability of intersect. But then we got B, we got that, we didn't have that. So make sure you write that. And we need to find those by knowing that probability of A times probability of B should be equal to 0.2. And only because it's independent event. So probability of A will be equal to 0.2 divided by 0.8. And therefore, we should get 0.25. So then we get back to here. So that will get you 0.25 plus 0.8 minus 0.2. And that should give us the answer 0.85. This is a question required integration because they give you a differentiated function and then they want the original one. So what we need to do is to let people know that you know that integration is required. So we have sine 3 2x cos 2x. First, this is a trick because they will make people think that it's by part, but there's more than by part here. So we don't need by part. We only need by substitution. So I have if I see that, I will see this one actually sine 2x bracket 3. So that means that our u will be our sine 2x. So u will be equal to sine 2x. So the u dx will be equals to 2 cos x, sorry. Yep. 2 cos 2x. All right, and then we need to rearrange this. So the 2 should be put it outside here. Because that's what we have here. So we just substitute it in. So u to the power 3 times 1 over 2 du dx dx. All right, this 2 neutralize out, and the 1 over 2 is a constant, so I'll throw it to the front. So now I have integrating u to the power 3 du. This should become in handy, so it's 1 over 4, 1 over 2, u to the power 4 plus c. So now I got 1 over 8 u to the power 4 plus c, rewriting it 8 sine 2x to the power 4 plus c. Now we have to find c by substitute that in. So we have 1. 1 will be equal to 1 over 8 sine 2 times pi over 4 all over 4 plus c. And then you got to have 1 over 8 times sine pi over 2 to the power 4 plus c. All right, now we get back to our function. Power 2 is 1. So we have 1 plus equals to 1 over 8 plus c. c should be equal to 7 over 8. Make sure you write the equation back so that they know what it is. So y equals to 1 over 8 sine 4 2x plus 7 over 8. This is our answer. This is a quadratic question, so we have this and this together intersect each other. So you might not see its intersect, but two distinct points. So which means that we'll have a weird function on those. So we will equal the two functions together to find the intersecting point. X minus m should be equals to m minus 1 over x. Multiply each of them by x, then you will have m x equals to mx minus 1. So you throw everything on one side, so x squared minus 2mx plus 1 equals to 0. Two distinct roots, so its bigger discriminant have to be bigger than 0. So we have negative b, negative m, b squared minus 4ac to get to be bigger than 0. Sorry, bigger. Alright, so we have 4m squared minus 4 bigger than 0, which for a quadratic equation, m squared would be equals to m. So, 4m squared equals to 4. So that will become plus or minus 1 here. So we draw the diagram. If you want, you can draw a sign diagram, you call it, or just sketch it. It's a positive, so it's go like this. We want it bigger than 0, so m have to be bigger than 1, or m have to be smaller than negative 1. Alright, coming up next, we have a long question here about vectors. So we have, first of all, we got OA and OB. Find AB. So which means that the one behind minus the one up, like B minus A, the one behind minus the one before. So we have 4, 1, 3 minus negative 1, 0, and 4, which gave us 5, 1, negative 1. Nice and easy. And then we need a magnitude for it. So square root 5 squared plus 1 squared plus 1 squared. So we end up, we have negative square root 27. Now we have another point here. We need to find the coordinate, show that it is that one. So AC should be equals to OC minus OA. So therefore, we will have 1, negative 1, 1, negative 1 equals to x, y, z. So we do not know C yet. So x, y, z minus the a here. So we have negative 1, 0, and 4, which give us x, y, z should be x plus 1 equals to negative 1. Which give us our x plus 1 is plus 1, throw it to the other side. So we got negative 1, and then 0 is 1, and then 4, throw it to the side, 3. So we got 3. No. Negative 2 here. So we got our coordinate of C. Now we got another triangle here. So we got that here. The line is extended, so it's a straight line. So angle ADB. So angle ADB in terms of theta, so this is a straight line. So that will become pi minus theta as the answer. Area of ABD. ABD. So that will be AD times BD sine pi minus theta. Since pi minus theta is still equal to theta, we can turn that into AD times BD sine theta. It should be the same. Now with the area of that area of these two triangles is equal to 3, show that. So all you need to do is, I'll put that here. So all you need to do is the area of AD times BD sine theta over the area of ACD. ACD, that one should be AD times DC sine theta should be equals to 3. So if we cancel those out, we will have BD over DC equals to 3. Throw it to the other side. BD should be equals to 3DC. Therefore, BD over BC, which is BD plus DC, should be equals to BD over 3BD, which is 3 plus DB. So we have 3 over 3 plus 1, we get you 3 over 4. Now, last but not least, cancel out otherwise, find the coordinate of D. So to find the coordinate of D, we need a bit of some work there. So we have a piece of blank paper. But previously, we got the information of those. We will have BD will be equal to 3 over 4 BC, because we throw this to the other side. And then now we have OD will be equals to OB plus 3 over 4 BC. Since BC is somewhere up there, let's see. BC will be equals to 213 minus 413. So that gives us should give us -6, 0, and 0. So we have that here. So OB is 413 plus 3 over 4, -6, 0, 0. So then we will have -1 over 2, 1, and 3. However, this is a vector. Therefore, the coordinate of D should be -1 over 2, 1, and 3. And this is our vector question. Here's another question here, and I would like to introduce my personal pen, like in limited edition. Anyway, so we have the first two terms of this, 2, and then it says you to be a geometric sequence. So R will be the one before, after it, minus divided by the one before. So we have log 2x over 2 log 2x. And therefore we got 1 over 2, nice and easy. So that, and then the next one, show that the infinite sequence of those. So we have our infinite sum will be equals to u1 over 1 minus r. So we have 2 log 2x over 1 minus 1 over 2. 1 minus 1 over 2 gets you 2 log square x over 1 over 2. We can cancel that out. So we can actually flip it over. So we have 2 log square x, log 2x times 2. So we have 4 log 2x, which gives us the answer. The next one is the AP here. We got different terms here. Given that D is an integer, so we need to find D. So I'll work it up here. So we have D, so we have log, D is the one after it minus the one before. So D should be equals to log x over 2 minus log 2x. So because it's minus, we can flip it over. So we have log 2x over 2 divided by x. So we can cancel that out. We have, and that gives us log 1 over 2, 2. So we have log 2, 1, -1. Therefore, we throw it to the front. We have -1 log 2, give us -1. And then D. Show that S12 is like that because it's geometric. So S12 should be equals to 12 divided by 2 times the 2 of the first term. First term is here. Log 2x plus 11, -1. So we have 6 times 2 log 2x minus 11. So therefore we have log 2 log 2x I'll leave it as it is. No, I'll write it nicely. So we have 12 log 2x minus 66. Given that s2 is half of the infinite sum, so we will have half of it. So we have log 2x minus 66 should be equals to half of the infinite sum, which is up here. Half of the 4 log 2x is 2 log 2x. So what we need to do is we put everything on one side. So we have 12 log 2x minus 2 log 2x will be equals to 66. So then we have 10 log 2x equals to 66. Yeah. So I'll write it the other side. So we have log 2x equals to 6.6. Moving a bit more, so x should be equals to 2 to the power 6.6, and that is the answer. Nice and easy. Alright, here is a long question here which I really like because it's really testing you on the differentiation concept on the differentiation. So first of all, we have cosine here, and then we need to differentiate it 4 times and then 19 times. So we have a first, we have differentiated fx is equal cosine, so cosine become negative sine, so we have negative sine x, and the second time sine become cosine, so we leave it the negative sign and stay it here. 3 times we have cosine become negative sign again, so we become positive sign, and then that becomes coming back to our cosine again. Alright, now the second bit is like they're asking you for the 19 times. So if we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, out of breath, 17, 18, 19. 19 should be here. So that should be equals to F3. Differentiate the third time, it gave us a sign again. So next bit, we will have our differentiated, the third differentiation of this bit, of this fella. So we copy that, gx equals to x to the power k, and then we move up k. So we have g dash x 3 times. So we have k, x, k minus 1. Second time, k still here, throw the index to the front. And then we have 3 times k, k minus 1, sorry, we get the same. And then k minus 2, and then we have xk minus 3. Now we want the 19 times here. We need to show that looks like this. We have a factorial here. We need to make it looks like factorial. So we move on. G19 should be equals to k and k minus 1, k minus 2 onwards, because this should be 1 less than that. So it should be k minus 18 and x to the power k minus 19. Now we need to put it into factorial. So in our mind, we need another color to think about that. K factorial equals to 1 times 2 times up to k. In reverse, we could put it into like k times k minus 1 times k minus 2 up to 1. So which means that if k multiply up to k minus 18, we need to divide that by k minus 19 factorial. So then we could have k factorial over k minus 19 factorial times x to the power k minus 19. Which means that the question asking what will be p. The p will be here, the 19. So p will be equals to 19 here. So moving on, we have k equal to 21, and we need to differentiate this bit. So now, which means that I need a new piece of paper. Yay. So which means that if hx equals to f19x times g19x, this is a product rule, needs to be quite a product rule because this is two things multiplied by each other. So h dash x will be equals to f, differentiate the first bit, 20x times g19x plus f19x times g20x. So to work with that out, we need to find out what we need. So previously we have f19x is equals to sine x. So f, differentiate this bit, should be equals to cosine x. And g19x, from our previous work, we got this bit here, this fellow here. So we have k factorial minus k minus 19 factorial x to the power k minus 19. And also the question, back to here, we're flipping it up and down. K equals to 21 here. So we will have 21 factorial minus divided by 21 minus 19 factorial x k minus 19. So, sorry, k is 21 here. We change that. So 19, 20, 21, so it's 2. So we have 21 factorial over 2 factorial, which is 2, x to the power 2. And then we need to find out g20. So we will differentiate it. So 21 factorial over 2. We throw the 2 to the front and x will be there. We cancel that out, we will get 21x. Now we put it together with this point. So we have h dash x should be equals to 20 cosine x, original bit here, 21 factorial over 2x squared plus originally sine x times 21x. And that is what we need here. Last but not least, we need to find out the h dash pi equals to something. So we need to put that into the equation. H dash pi will be equal to cosine pi 21 factorial 2 pi square plus sine pi 21 times pi. Now sine pi is equal to 0, so this bit will be gone. So we will have cosine pi is 1. So we have 21 factorial over 2 times pi squared, which is our answer here. And this is our question 10.